Good morning, everybody, and welcome to our next video on how to find areas of circles and sectors. Okay, I'm going to leave something up here in the corner. This is section 10.7. I'm going to try the sideways view today. Hopefully you'll like it. Remember, if you have a circle of radius r and you want to find the area of that sector, all we did is we took x divided by 360, multiplied it by pi r squared, right? Sorry, it's a little wobbly. Hopefully I won't shake so much. Okay, so today we're going to learn what happens if you take that same sort of circle and instead you have this cute little sliver of area right here. This is what we want to find the area of, which is really cool. So I'm just going to do a really nice one. Let's call this 60 degrees. Let's call this a radius of 4. Okay. Now, if you think about the general procedure here, and you want to find the area of just this little sliver right here, we're probably going to take the whole sector, right? Subtract off the triangle, and we'll be given just a little sliver. This is pretty intuitive, actually, okay? So that's all we're going to do. We're going to take the sector minus the triangle, and we'll get the sliver. Now, remember, the sector is whatever I am divided by 360 pi r squared. But a triangle, we have tons of different ways to find areas of triangles, right? So I would like to show you / tell you / remind you there's a really, really great area formula for a triangle that we're going to use, and it's 1/2 AB times the sine of C. It's really, really handy. All you got to do is, if you know this angle right here, just go 1/2 times this times the sine of the included angle, the angle in between these two. Really, really, really great. Of course, since it's a 60 degree, you could use your equilateral triangle formula. If it's a 90, you can use 1/2 base times height, but this works for every single triangle in the world. So I'm just going to use 1/2 AB sine C, and then that will produce what I want. So nicely on this one, I've got 63/60ths of pi 4 squared minus. Now, if you look at this triangle right here, it's got a 60. Sorry, it looks a little off. And this is a 4, and this is a 4. So all you got to do, really nice, is just go 1/2. Sorry, it's kind of, the light is kind of shadowy. There we go. 1/2, this sine of this. 1/2 times 4 times 4 times the sine of the included angle. It's going to be a pretty small area, huh? It's going to be a really small area. I mean, if you think about this, with what's going on here, you've got the whole triangle is 16 pi, right? Not circle, I mean. Now think about this for a minute. 50.26. So this whole entire thing is like a little bit over 50. So this guy is going to be super cinchy, super small, super small. So this is 1/6 of 16 pi minus, this is 16 halves, 8 sine 60. Well, who cares about all that? I'm just going to go 16 pi divided by 6, and you could do this separately. There's my 8.377, so this one's about 8.37778 minus 8 times the sine of 60, 6.92-ish, and that produces, now I'm just going to use my calculator, and the nice thing about these is you can just arrow up and find it. Oops, what did I just do? Okay, let's do that again. That one minus that one, tiny, whoa, 1.449. This is super small, but that's okay. That's the whole point. Nice little shaded area region. Now we're going to do a couple more here, just so you see, but that is really all you have to do. And I'm going to do kind of an interesting one. We'll do like what happens when you have like maybe a I don't know, 110 degrees. Big old okay. I would like the 110 degrees is right here. This is a radius, I don't know, 10. Okay. 110 degrees. Well, whether or not you want to think about all the different procedures or not, that's fine. I always like to kind of think about this as, all right, I've got my sector. I'm going to take away my triangle, and I'm going to get my sliver. So I think about the different procedures. So this guy is going to be 110 3/60ths of pi r squared minus, oh, there we go again. Now you could always take this triangle and drop down the middle and find an altitude by using trig and do 1/2 base times height, but this is really kind of nice and simple. I'm not going to jiggle so much. And I got 1/2 AB sine of C with this included angle. And I'm just going to let my calculator do the work. Well, okay, so 110 divided by 3/60. You could reduce the fraction or whatever, and you can multiply that by 100, and that's really nice. And if you math frac that, that's like 275 ninths. Well, since we're going for calculators anyway, we might as well just use it. So that's like 95.99. 95.99. Now that's kind of interesting. That should be about 1/3 of the whole thing, right? And if you think about what 100 pi is, 100 pi is a little bit over 300, obviously. 314. So that looks like it's about 1/3. Looks like we're on the right track. But then 100 divided by 2 is 50. So 50 times the sine of 110, 46.92, 98, I mean. So this ends up, I'm just going to do this. This ends up being, using my handy dandy calculator, this minus this is 40. Whoa, that's kind of pretty. 49.008 is the area of that. That's kind of a big answer, but that's a big region, which is cool. Okay. Now, interestingly enough, that's the whole idea. Find the area of the little triangle, whatever it is. And of course, I could do something like, ooh, here's a circle of radius 6, and what I would like you guys to find is, this is like 31 degrees, is, now watch this, is this area. And they'd be like, what? What's the formula for how do I find the area of this whole thing? Well, I don't think I'm actually going to do that. But what I think I'll do, well, I guess there's a lot of different ways you could do it. You could find the 329 3/60ths of 36 pi plus 1/2 66 sine 31. Or you could do this whole procedure here, find your area of your sector and your area of your triangle and subtract it to find the sliver, and then subtract that sliver off of 36 pi. It doesn't really matter. Either way you want to do it is okay. And lots of different things. So there's going to be a couple questions like that. This is your homework sheet. Really nice and simple. There's a tiny little sliver here. Really nice little idea. And then these four are the shaded area sort of thing. It says leave in terms of pi in radical form. You could just do it as a decimal. That's fine with me. And then a few application type of questions, which is cool. But these are pretty straightforward. 11 of the cutest little problems you've ever seen. But I think I'll just, for bonus, you can be done now if you want, or for bonus, I'm just going to go, all right, let's go 329 3/60ths of pi r squared plus, now that was this part, the 329 plus 1/2 66 sine 31. Now, it's going to be a little bit of a magic trick here. Okay, so this is going to equal something. But then somebody else goes, no. What I'd rather do is do the boop minus boop equals boop, and then do 36 pi, the area of the whole circle, minus that. Okay, so these should equal the same thing. So here's 31 3/60ths of pi r squared minus 1/2 AB sine C equals, and this is going to go right here. We could probably do a little bit of identity work here to try to show those are equal, but I'm just going to use my calculator. All right, let's see if this magic trick works on a Wednesday morning. 329 3/60 times pi times 36. I'm going to do it all in one swoop, like you guys can too. Plus, now 36 halves is 18 sine 31. Now there's my first answer. Okay, 112 point. I gotta think to myself, 36 pi. That's like 113. So this is looking good. This is looking good. Like this could be it, because it should almost be the entire thing. So I'm going with this 112 thing. 112.629. All right, I'm going to confidently say that. I'm just going to check and see. If I can get the same answer both ways, I think that would be fantastic. So now I'm going to go 31 3/60 times 36 pi. That's that part. Minus 36 halves is 18. That sounds familiar. 18 sine 31. Okay, now there's that. But that's what I want to take away from 36 pi. So 36 pi minus answer. Come on, drum roll, please. The better equal one. Drum roll. Oh my gosh, how great is that? 112.629. Either way you do it, of course, which is really, really, really great. And what a cute little problem. So nice idea. All you got to do is find the area of the little sliver using the techniques that we talked about today. Okay, so go to the 10.7 second day worksheet.